Assalamualaikum warahmatullahi wabarakatuh. We from Group 7 will present to you about our Pbl. Okay, first, my name is Muhammad Farid Garaniza. The second one is Muhammad Faris Hafizuddin Birosli. The third is Muhammad Faris Izzat Birosman. The fourth is Muhammad Faris Izzuddin Bizuki Izzuddin. This is all my team, and I will introduce to you about our Pbl. First, introduction. The first one we will look forward is Newton's law of cooling. The temperature of many objects can be modulated using a differential equation. Newton's law of cooling for heating state that the temperature of a body changes at a rate proportional to the difference in temperature between the body and its surrounding is reasonably accurate approximation in some circumstances. More precisely, the equation we know that I show in here. That's T the net to the temperature of an object, and TE the ambient temperature, T the relative, and Newton law state the equation dt per E over dt equal to negative K, where K is positive constant. Thus, the object is much better. If the object is much hotter than its surrounding, we can consume that T negative T E slash and positive. So dt over dt slash and negative. So the object cools quickly. If the object is only slightly hotter than its surrounding, we consume that T. We assume that T minus T E is more positive and object cools slowly. So a cup of coffee will cool more quickly if you put in the refrigerator. The next one I will explain to you about population growth. We consider the equation is the dP over dt equal to Kp, where T and P are variable and K is constant. K not equal to 0. As equation involving derivative, this is example of a differential equation. We often think of T as measuring time and P measuring some quantity over time. Basically, P is a function of time. Okay. From this picture, you can see the equations. Okay. There are many quantity in the real world that approximately obey an equation similar to this one. As we will see shortly, we first the equation in general. Okay. For me, I will pass to my friends.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris Izzat Birosman, and I am going to present about problem background. For the first part, which is part A, the problem is a detective finds a murder victim at 9 AM in a room that is kept at a constant temperature 20 degrees Celsius. The temperature of the body is measured to be 32 degrees Celsius. 2 hours later, the temperature of the body cools to 13 degrees Celsius. Assuming that the body temperature of the victim when the murder occurred is 37 degrees Celsius. So, we need to find at what time did the murder occur. For part B, the problem is the population of rabbits on an island is modeled by dx per dt equal to x minus 1 per 1000 times x to the power of 2, where the independent variable is time in month. At time t equal to 0, there are 40 rabbits on the island. We need to find the solution to the equation with the initial condition, and also we need to find how many rabbits are on the island in 1 month, 15 months. Thank you.
Assalamualaikum and good morning. My name is Muhammad Faris Izzuddin. Today I'm going to present about Pbl table. Firstly, I'm going to read the problem statement. The detective finds a murder victim at 9 a.m. in a room that is kept at a constant temperature of 20 degrees Celsius. The temperature of the body is measured to be 32 degrees Celsius. 2 hours later, the temperature of the body cools to 30 degrees Celsius, assuming that the body temperature of the victim when the murder occurred is 37 degrees Celsius. At what time did the murder occur? Okay. The facts that we have obtained from the problem statement is: first, the detective finds a murder victim in a room with constant temperature of 20 degrees Celsius at 9 a.m. Secondly, the temperature of the murder victim is 32 degrees Celsius when found. Thirdly and lastly, after 2 hours, temperature of body cools to 30 degrees Celsius. The ideas to solve the problem statement that we have obtained is: firstly, the solution for this question is using Newton's law of cooling. Secondly, heat from the body transfer from hotter place to colder place. And lastly, the initial temperature of the body is 37 degrees Celsius. The learning issues. Number 1. Which topic that is linked to the question? Number 2. Which subtopic used to obtain the solution? Lastly, what is the cause for the body temperature to decrease? Action plan and resources needed. Number 1. Obtain the value of constant K by using Newton's law of cooling formula and solve the question. Secondly, we use Engineering Mathematics reference book. Third and lastly, we refer to Mr. Zul Arifin Ma'ruf YouTube channel. A population of rabbits on an island is modeled by dx over dt equals to x minus 1 over 1000 times x power of 2, where the independent variable is the time in month. At time t equals to 0, there are 40 rabbits on the island. A. Find the solution to the equation with the initial condition. B. How many rabbits are on the island in 1 month, 15 months, and round to the nearest integer. The fact from the problem statement that we have obtained is: firstly, the population of rabbits on an island is represented by dx over dt equals to x minus 1 over 1000 times x to the power of 2. Number 2, the time is in months. And lastly, during t equals to 0, there are 40 rabbits on the island. The ideas used to solve the problem is: number 1, the topic is about chapter 2 of Engineering Mathematics, which is population growth model. Number 2, rearrange the equation to make general equation. And lastly, population growth calculation method used to solve this problem. The learning issues. Firstly, what topic can be linked to the problem? How to solve the equation? Which subtopic in that chapter can be used to solve the equation? Lastly, why do we need to investigate the rate of growth? Action plan and resources needed. Firstly, substitute the value given to solve the equation. Secondly, use initial condition to obtain the number of rabbits in 1 month and 15 months. Thirdly, all the method above is referred from the Engineering Mathematics reference book. Lastly, we refer to Mr. Zul Arifin Ma'ruf YouTube channel.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris bin Nusri, and today I would like to present to you our problem solution for question part A 10 and question part B 1. So for part A question 10, the DE for Newton's cooling or warming is as shown above. So we can use the given information such as the temperature of room is 20 degrees Celsius. So we can conclude that the Tm is the 20 degrees Celsius. After that, we can substitute the value of the initial condition. T0 is equal to 37 degrees Celsius, and we will get the first equation, which is t is equal to 20 plus 17e to the power of kt. So the next is we can use the equation to insert the temperature of the body at the moment, which is 32 degrees Celsius. Therefore, after substituting the given information, we will get 12 is equal to 17e to the power of kt1 as the first equation. After that, we can substitute the information which is temperature of the body after 2 hours, which is 30 degrees Celsius. After substituting, we would get 10 is equal to 17e to the power of k in bracket kt t1 plus 1. And after that, we can divide the first equation with the second equation. So we will get k, the value of k, which is k is equal to negative 0.18. Then we can substitute the value of k into the first equation, and we will get the time, which is 1.64 hours. Therefore, we could minus the time we get with the original time the body was found. Therefore, we could get the time when the murder occurs, which is 7:04 a.m. So for the question, part B, question 1, there are two questions, question A and B. First, we can solve for question A. Question A, we should use the given equation, which is dx over dt is equal to x minus 1 over 1000 x square. We can integrate the equation to get ln x is equal to, we can integrate and rearrange the equation, so we will get ln x is equal to negative x to the power of 3 t over 3000 plus c. And after assuming, and we will get the final equation, which is x is equal to p naught e to the power of negative x to the power of 3 t over 3000, and we can assume t equal to 0 to conclude p naught. Then the solution for B. The question requested us to find the value of rabbit after 1 month and after 50 months. So we can solve for 1 month first. So we can insert the value of t is equal to 1 into the equation, and after inserting, and we will get the total of rabbit after 1 month is 18.61 rounded off to 19, which means that the number of rabbit in that island after 1 month is equal to 19 rabbit, which shows that the number of the rabbit on the island is slowly decreasing. After that, we can solve for 15 months. We can insert the value of t is equal to 15 into the equation, and we will get the total number of rabbit after 15 months is 9.457 rounded off to 9 rabbit, which can be concluded as the number of rabbit on the island is slowly decreasing too. That's all. Thank you.